This tutorial describes the operation of the device WL308, which is utilized to understand the fundamentals of concentric tube heat exchangers. In general, a heat exchanger is a device engineered for the exchange of thermal energy or heat between two fluids that are at different temperatures and separated by solid walls. Heat exchangers can be classified according to flow arrangement and type of construction. The first classification is concentric tube or double pipe, where the cold and hot fluids move in the same or opposite directions in a configuration of concentric pipes. The configuration where the fluids move in the same direction is known as parallel flow, whereas the counterflow configuration refers to a heat exchanger where the fluids move in opposite directions. The second classification is cross flow. One fluid flows perpendicularly to the other. The final classification is a shell and tube heat exchanger, which is a more complex system that consists of a larger vessel, also known as a shell, which contains a relatively large number of tubes. In today's lab, we will focus on configuration 1, the concentric and parallel flow heat exchangers. The objective of this laboratory is to understand heat transfer in heat exchangers of counter and parallel flow configurations. From the experimental data, students will be able to calculate convective transfer coefficients, overall heat transfer coefficients, heat exchanger efficiencies, and draw engineering-based conclusions and comparisons between heat exchanger configurations. The device WL308 allows the study of a concentric heat exchanger that can operate in parallel and counterflow configurations by switching a set of two three-way valves. The heat exchanger section consists of two 560 mm long concentric copper pipes. The inner pipe transports the hot water in an upward direction, whereas the outer pipe transports the cold water in either an upward or downward direction. Parallel flow is achieved when both the inner and outer flows run in an upward direction. The counterflow configuration is achieved when the cold water flowing in the outer pipe runs in a downward direction. The heat exchanger pipe is equipped with temperature sensors that measure inlet, outlet, and midway temperatures of the fluids, as well as the outside wall temperature of the inner tube. Volumetric flow controllers allow the adjusting of flow rates of both cold and hot flows. Knowledge of the fluid temperatures, fluid property, wall temperature, and volumetric flow rates allows for the calculation of characteristic parameters of the heat exchanger. We will now review the main components and controls of the heat exchanger WL308. The main switch powers the system on. The concentric double pipe acts as the heat exchanger. The inner tube contains the hot water, which always flows upward. Cold water flows in the surrounding outer tube. The cold water flowing downward creates the counterflow configuration, whereas cold water flowing upwards creates the parallel flow configuration. Cold water inlet and outlet lines are connecting to the building's water inlet and outlets. Hot water coming from the hot water tanks is pumped by the water pump. The pump provides a pressure differential to move the hot water through the system. The hot water tank contains an electric heater that raises the temperature of the water to the value set by the user on the temperature controller. The water temperature can be adjusted by the temperature controller to a maximum temperature of 60 degrees Celsius. Two three-way valves that define the heat transfer configuration or operating mode. These valves change the flow direction of the cold water. When the valve handles are in vertical and anti-parallel position, the heat exchanger operates in parallel configuration. When the valve handles are in horizontal and anti-parallel positions, the heat exchanger operates in the counterflow configuration. A rotometer for the cold water inlet ensures that water is flowing through the device at the appropriate rate, and a rotometer for the hot water inlet ensures that hot water is flowing from the heater to the heat exchanger at the proper rate. These flow rates can be adjusted using the black valves located by either rotometer. 7 temperature sensors are located throughout the device. These sensors provide the inlet, center, and outlet temperatures of the hot and cold water and the outside temperature of the inner tube. Refer to the lecture slides and device manual to see the specific location measured by each temperature sensor. The display shows the reading of a chosen temperature sensor. The knob below the display allows the user to choose the temperature sensor displayed. In this video, we will describe an experiment in which the heat exchanger is used in parallel and counterflow configurations with various volumetric flow rates. Remember that in this device, parallel flow is achieved by turning the top three-way valve handle vertically up and the bottom handle vertically down. Counterflow is achieved by turning the top handle horizontally right and the bottom handle horizontally left. Note that the flow rates and temperatures depicted in this video may vary from other laboratory activities. Refer to the laboratory guide provided for specific details. Before operating the machine, make sure to wear safety goggles, adhere to the laboratory safety rules, and ensure the hot water tank is appropriately filled by checking the level through the seeing window. Filling the tank with water is typically performed by the TA. We are now ready to begin turning on the machine. Open the inlet and outlet water lines to the right of the machine in the laboratory room. Slightly turn the cold water black inlet valve to the left of the main switch to ensure there is water flow in the cold water inlet pipe. Locate the main switch and switch it into the on position. Using the same cold water inlet valve, set the volumetric flow rate to the desired value. Check the laboratory guide for further information. Using the red and green switch, turn on the heater and pump by pushing on the green side. Locate the black hot water valve to the left of the main switch. Turn the knob to set the volumetric flow rate to the desired value. Refer to the laboratory guide for specific details. Using the heater controller next to the heater pump valve, adjust the temperature to the value given in the lab manual, in this case 60 degrees Celsius. Perform this task using the arrow up and down buttons. Select the OK button once the desired temperature is reached. Locate the temperature display and dial above the heater controller. Use the dial to cycle through thermocouple readings of each temperature sensor. There are 7 possible temperature options, which are labeled as T1, T2, and so on up to T7. Wait until the heat exchanger has reached a steady state. Manually record all temperature values for each set of volumetric flow values when the device has reached equilibrium. Ensure all data recording has been completed and properly recorded. The data recording portion of the lab experiment is now complete, and machine shutoff can begin. Turn off the hot water valve. Using the red and green switch, turn off the heater and the pump. Turn off the main switch. Be sure to complete these steps in the proper order listed. Wait 5 minutes before turning off the external cold water valves, allowing the machine to properly cool.